So if we look at this equation, let's go ahead and factor all of our denominators so we can really see what those factors are. So we get 2 over x plus 2, x minus 2, since x squared minus 4 is a difference of squares, plus 1 over x minus 2 equals 2 over x plus 2. And now we can see that our least common denominator is x plus 2 times x minus 2. So when we multiply all three terms in this equation by x plus 2, x minus 2, we can see that in the first term, the x plus 2, x minus 2 is going to cancel completely, leaving us with 2x. When we multiply this term by x plus 2, x minus 2, the x minus 2's cancel, leaving us with an x plus 2. And here the x plus 2's cancel, leaving us with 2 times x minus 2. So we have 3x plus 2 equals 2x minus 4. Subtract 2x from both sides leaves us with an x. Subtract 2 from both sides leaves us with a negative 6. And if you plug in x equals negative 6 into our original equation, you can verify that our solution is indeed correct. So if we want to solve this rational equation right here, the first thing we should do is factor all the denominators. So this becomes 1 over x minus 1 plus 1/2 equals 2 over x plus 1 times x minus 1. Because x squared minus 1 is a difference of squares, so we can see how that factors. Once we have it in this form, we can see that the least common denominator is going to be x minus 1 times 2, and then we pick up a factor of x plus 1 right here. So we have x minus 1, x plus 1, and then that 2 factor from here. Okay. So when we multiply this entire equation by this least common denominator, that is all three terms in this equation get multiplied by this, well, the x minus 1 cancels in the first term, leaving us with 1 times 2 times x plus 1. When we multiply the least common denominator times the 1/2 and the 2 cancel out, leaving us with x plus 1 times x minus 1. And when we multiply this term on the right by our least common denominator, both the x plus 1 and x minus 1 factors cancel, and we get 2 from here times the 2 that's left over in our least common denominator, leaving us with 4, giving us 2x plus 2 plus x squared minus 1 equals 4. Or x squared plus 2x minus 3 equals 0, which factors as x plus 3 times x minus 1 equals 0. So x equals negative 3, or x equals 1. We want to verify both of these solutions, so let me rewrite our original equation right here. And we can see if we plug in negative 3, you go through and work it out, you'll get a true equation. But we have a problem when we go to plug in x equals 1. When we plug in x equals 1, we get a 0 in a denominator, which is not allowed. So x equals 1 is not actually a solution to the equation, but we keep x equals negative 3, so x equals negative 3 is our solution. And the 1 gets rejected.